Y'all haters corny with that.
So today we're going to be talking about quadratic cousins, and that's when an equation looks like it could be a quadratic equation, but it's really not. They may share similar properties and traits, but the only way to tell that it's a quadratic cousin is if the first variable in the equation is raised to a power that is twice of that of the middle variable. And the way that you break it down into smaller parts that we can make into a quadratic equation would be to substitute that middle variable of x to whatever power that it's originally raised to. And when you do this, you change the variable letter from an x to a u. And in this first example, we're going to raise the first variable of x at the beginning to a power of 4, and then raise the corresponding middle variable to a power of 2, because the variable in the middle is always exactly half of that first one. So instead of x to the 4th, we're going to substitute it as u squared minus 20u plus 64 equals 0. And from there you want to factor out what multiplies to be 64 and adds to be negative 20. And in this case, it's going to be 16 and 4. So then you have to take the square root of x squared to find your two x values for each one, because x can be plus or minus those values multiplied by each other, which is why there's a positive and a negative. It's always important to check every equation you do in algebra, and this is no exception. So the way you're going to check these kind of problems is you plug in one of the values that you got into the original equation. The first value we're checking here is 2. And your goal is going to be to make your original equation with the value that you plugged in equal 0. And as you can see, this works out quite nicely in this example. So that first one was pretty easy, right? This next one is going to get a little more difficult. So in our previous example, the first variable we had was x to the 4th, and that's obviously going to be the largest one. But that doesn't necessarily have to be the first variable for any given problem. Your variables could even be fractions, such as the first one being 2/3 and the second one being 1/3. And basically all we're saying here is that as long as the variable in the middle is half of the first one, that's the easiest way to identify a quadratic cousin. And notice in this second example, our first variable is x, and our second variable, which is half, would be the square root of x. The first thing here would be to move over the 1 to make it equal 0. From there you substitute u in for the square root of x, bringing you 4u squared plus 3u minus 1 equals 0. And you want to see what multiplies to get negative 4 and adds to be 3. And it looks like that's going to be positive 4 and negative 1. Once again, you want both of those values to equal 0 once you calculate them. Flipping both of those values would land us with u equaling 1/4 and also u equaling negative 1. Since u was originally substituted for the square root of x, you now have to find the actual value of x by plugging in those values you got for u and squaring them. Again, we checked our work and we found that one of the values was not possible because it was an imaginary number, but our other value, 1/16, was still good.